So today I am going to talk about the renormalization group explanation, and I will provide a principal account to capture the RG explanation. Oh, second. Okay, so this is the whole structure of the presentation. So before talking about the RG, I will give some background debate about it, and then I will try to introduce what kind of question the RG is to answer, and then I will to illustrate what kind of answer the RG give to respond to those questions. So if we have some time, I will also talk about a potential objection to my theory. So the background debate and the end. So before talking about RG, I want to introduce the two mainstream theories of applied mathematics and the scientific explanation. The first theory is called structuralism, which says the mathematical applied in virtue of mapping a mathematical structure onto the target system. And then the second theory is summarized by the Rotman and Rice, which says that a model explained in virtue of citing a common feature shared by the model and the target system. And I should also emphasize that this is only a minimal requirement for accounts of scientific explanation, and I will talk more about it in the third part. So the challenge from the RG is that to attain RG transformation, we require mathematical singularity, which is called the thermodynamic limit. That is, the number of particles in the model approach infinity. So here we cannot really find a mapping between the physical reality and then that limit. So it seems to us the structuralism or the commonality theory, they cannot really accommodate the RG explanation. So this is the first challenge. The second challenge is about that. It's about the methodology of the RG explanation. So to cash out RG explanation, we really realize on some minimal model, and minimal model is highly idealized of the physical reality. Basically, we just depress the old physical properties, and we only remind what we taken to be really crucial for the explanation. And Butterman and Rice point out the commonality itself is part of explainant. So if we just citing the commonality between the minimal model and the target system, we do not fully capture how RG explains. So there are three direct responses. The first response is from Bruno and the French. They say that it's unclear why taking the limit has an explanatory role, and Satie and Rotlinger goes further, and they argue that the limit is merely instrumental in this principle and contribute nothing to the explanation. And there are many other scholars who think we do not really need to any spatial theory to account the RG explanation because the mapping between the minimal model and the target system is already sufficient. So the end of this paper, I really felt that the previous discussion focused too much on thermodynamic limits, and it seems to me they didn't give too much focus on whole RG explanation. So this is what I want to do here. And I really want to think out what is the subtle explanatory structure or the character of RG. And in doing so, I want to give the hotchpotch picture to reconcile the insights from the commonality theories and the insights from the Bartman-Rice critique. So part 2, the questions, the RG answer. And so what kind of questions RG answer? We call it the universality of the critical phenomena. So the critical phenomena involve the second order transition near the critical temperature. So we can just look at the right diagram here. This is the PVT diagram for water systems. So what interesting here is that if we if the system's temperature is below the critical temperature, so when water want to change from liquid to the gas, it must be go through the liquid gas coexistence status, and we all learned it before. However, now what is really interesting is that when the system temperature is above the critical temperature, we can just change the liquid to the gas in a very continuous rate. And physically speaking, there's no really distinction between the liquid and the gas. So this is the critical behavior. And more than that, physics also found that when a water system is very close to the critical temperature, many thermodynamic properties obey the power laws governed by a dimensionless constant called the critical exponent, and we use the Greek letter to denote it. So these thermodynamic properties include the liquid gas density, heat capacity, and magnetization. Yeah, and then these can go through. And I will give a very simple example here. So we just take the liquid gas density difference here. So, and we're calling it as an order parameter, and we're calling it as a modern parameter because it's a feature how orderly the water system is, right? So, and yeah, so, and we find the order parameter is proportional to a function or to a power law function, which is characterized by the critical exponent beta. So I think we can use the other more visualized way to understand this formula. It seems like we can just see the shape of the coexistence region in the PVT grain. So yeah. So this is the critical phenomena. So now we are going to understand what is the universality of the critical phenomena. So what is interesting here is that for many molecularly distant fluids, like water, like an oxygen on a CO2, or even for some magnets, they correspond order parameter or obey to the law of the same critical exponent, such as the formula I just gave. So, and we can still use this diagram to see for illustration the shape for this system, which is made by the so different materials, and their order and then the shape for the coexistence status are the same. And we call all such systems being in the same universality class of beta. So why this universality is an interesting question? Because for physics, these universalities does not really just coincident. It seems very robust. So let's think this is very interesting. So so why this is okay, and I also give that the molecular distance systems sure have performed different macro scales behavior due to their distinct macros constitution. So because these are so different systems, they should perform in a different way, but they do perform in the same way. So that's weird, right? And it's so the question for those physics is to how do we inquire them. So in the following slides, I am going to introduce the 3 ways to understanding all the ask question about the universality. So is the universality 1. Why do systems that are heterogeneous at the micro scale exhibit the sense pattern of behavior at the macro scale? So this is quite a natural way to formulate the questions, and it seeks for the robustness of critical behavior from the change of micro detail. However, as Sasti and Rotman point out, not all systems perform identical critical behavior. Only systems in the universality class perform it. And more importantly, and this way of formulating the question cannot rule out in the case of the 2 molecular systems happen to exist in the same property of all behavior. For example, we can take a ordinary life case, like we have the grains table and we have a grains pens. However, and we can categorize them into the same class of being grains, but it seems like this. It seems like it is quite meaningless to ask why they share the same properties when their molecule, when their the physical nature are so different, right? So, which leads us to the second ways of question formulating. Why there is a university class in which systems experience the same patterns of behavior at the micro scale. So I think this is more strong way to formulate the question, and it seeks the common feature between the systems and in a sense university class. For example, we just take a look at the empirical table obtained from the experimentation. And we can take a line 3 as example. If we fix the spatial dimension for the system and the symmetry number of order parameters for that system, we can determine what's the value of the critical exponent. Actually, and those physics has achieved a lot before doing the RG explanation to do that. So this actually reached a very interesting questions, because it seems to me that the universality truth cannot distinguish between RG explanation and the explanation appealing empirical law, which characterize relationship between the common feature and then the critical exponent. Because if we just ask why there is a universality account, I think physics has already given a lot of empirical generalization before we using the RG method to predict them. So So I think the universality truth is still weak in some way. So I introduced the universality 3 to composite the formal truth way. So why there is a universality class in which systems heterogeneous at the micro scale exhibit the same pattern of behavior at the macro scale. So I should emphasize this is a composite question of the universality 1 and 2, and we formulate this question into 2 steps. The first step is to ask why there is a class. The second step is to say, in that given class, why do systems heterogeneous at the micro scale exhibit the same macro behavior? And the other way to formulate the step 2 is that we to say why the class is depends on a common feature indicate from the experimentation. So I think there are two advantages of adopting Universality 3 than 2. The first is to avoid the Universality 2 cannot rule out, that is, as I mentioned, the coincidence that universality class happen to occur correlate with the common feature in the question. And then the second advantage is more about the methodology of the RG explain. As I mentioned above, the minimal models and when we applied the RGs, we both applied the minimal model and the target C system, which generates a new questions. How the minimal model apply to the target system? If we just appeal to the commonality between them, we didn't seem to really answer the question, because what we really want to say is that we already know they already share some common feature. So how the minimal model can explain the target system? So that's why I say here the focus on the explanation has been shifted. We are now shift the focus to the why the macro scale behavior of a specific system in the universality class lose the connection to its micro constitutions. Yeah. So now I just read it loud about the hotchpotch thesis. So it seems to me the answer to the universality 3 is not one stage process, but a multi-stage process of identifying the common feature influencing from the feature to the universally critical behavior, justifying the universality by ruling out irrelevant details that distinguish target system far from the critical quality. And this multi-stage process is iterative. One must continuously rework the previous stage and reach a first stage until the question is being answered. And we call this iterative multi-stage style explanation, hotchpotch picture. So there are one very important feature of it. So it is the two sub-questions for the university tree is interconnected, because we must, when we answer the second question, we already know the, we are already based on the first one, right? But if we really want to get the, to justify our answer for the question 1, we must answer for the second step. Yeah. So now I'm going to the answer part that RG gives. So the RG explanation is quite complicated. So I just leave the whole technical part out. And so I just introduced the general structure. So as we see, like all different molecularly different system perform the same micro-scale critical behavior. So which means maybe we can just only need some very a few modeling parameter to describe a system. So which really want to us to reduce the number of modeling parameter for systems. And the RG explain, so this lead us to the second step, which is to find the average root to K-shot RG transformation or RG flow to wash out the micro detail of the system. So we can just look the right diagram here. And suppose we have a lot of particles, and those particles all have two properties. One is spin down and one is spin up. And we also know those properties are interact in some ways. So how do we understand it? And we can just say, so if we zoom out from the system, so perhaps for us, the block of the particle can be replaced by a bigger virtual particle, and whose property can be transformed or rescaled in by a function which is related to the particle and their property in a lower scale. So in this sense, we can do this replacing one and once again, and we can even see the 9 block of particles by replaced by a bigger virtual particle. So what is interesting here is that, and we can just look the illustration below. Each plane denotes one each physical system, and we can just do the average root to length once again, and we just straight out RG flow from it. So if we are lucky, and we can find scales in variant pattern of behaviors in which the micro detail can be in which that some micro detail can be washed out, but some pattern are really reserved. They are really scaled to a upper scale. So the striking fact is that a large class of systems under this RG float are tracked to the same fixed point, which is a topological structure which characterizing the critical behaviors we aim to pay. So which means here is that we can just do RG flow to each physical system, and if they can drop out to one fixed point, we can just define a universality class for these to such different systems. So this is the whole point. Okay, so now I go into the philosophy part, and I will go into quickly. So as I said before, there are two theories. The first theory is about the commonality theory, which says an RG analyze explain universe effects by citing common feature shared by the molecularly distinct system, and showing that the common features are sufficient for an identical macro-scale critical behavior. And then the second theory, which is seemingly opposite, is provided by Rotman and Rice. They argue that an RG analyze explain universality fact by showing the independence of critical behavior from the irrelevant heterogeneous micro detail. So it seems for many previous scholars, these two theories are really conflict. But in this paper, I really want to argue that no, they are not really conflict, and we can just make a lens reconciled and contribute to our understanding of RG. So I think they correspond to the two aspects of RG. The first is about the relevant part, so which is a question of what experimentally relevant factors are and how they relate to the explained universality. And the second is about the irrelevant part, which means we can distinguish about what are the irrelevant factors and how they are washed out. So in a following slide, I will first introduce a more advanced commonality theory, which is called a counterfactual theory of explanation, and then I will go into the law of irrelevant theory. So now we are going to the what I call CTE here. So it says explanation is to answer how the explained phenomena would differ if the factor cited in the explainers has been changed in a certain way. So it has the three conditions. The first condition says that the formula we get and the boundary condition we get and the design results we are trying to give are all true, all are close to truth, right? And the second is that from the formula we have and the boundary or boundary condition or the initial condition we have, we can derive to the result we want. And then the dependency, the third condition, is what I want to focus on in this presentation. It says that the formula provides at least one counterfactual such that has had as being different than they are actually are, then then the explainers or the conditional property of it will be different. So we can see how to apply the CTE to RG explanation. So the RG explained by giving counterfactuals and such that if a physical system has a different spatial dimensionality than it actually has, then S will be in such a different university class than it actually is in. And and we can also get when we switch the value of the symmetry of all the parameter, we can also switch the values for the universal class, which is the critical exponent, right? So we switch the value, the common feature value, and we switch the and which leads us to the change of the membership of the universality class or the value of critical exponent. So, however, the Halifax ETL and in 2019, they argue that the CTE does not really succeed in general because the CTE cannot rule out the empirical laws that are penetrate. So we can take more laws as examples, and the Moore law is really an empirical law, and it can satisfy the three conditions of CTE, right? Because they are true, and we can derive the right answer, and it can provide the counterfactual. But the Moore law is not explanatory, but only a correlation between the year variable and the number of transistors per chip. Similarly, we can apply Halifax critique to the RG to the CTE's application to the RG explanation. As I said about before doing the RG explanation, physics has already summarized a lot of empirical generalization. They can just give the systematical table to give the relationship between the common feature and the corresponding critical exponent. So it seems to me this table on the empirical laws can also provide can also satisfy the CTE, but they are not really seem to be explanatory. So to avoid this issue, I think we can just introduce the interventionism. So this required to introduce in the interventionism to clear out a path from the variance in the value of explainers variable to the variation in the explainers variable. So I just give a simple illustration to what I mean here. So we really want to show it is the intervention on the variable x to y, and we can just introduce what would count for the causal explanation here. We need to rule out the common cause or some superfluous correlation from the intervention to the variable y. If we can rule out them, then we can get the causal explanation from the variable y to x. So now I just introduced the interventionism. Says that the formula supports a counterfactual that if had intervention on the explainers variable a, which switch its value, then the explainers variable e will switch its value as a result of intervention. So however, there's a very quick issue here. The interventionism is about the causal explanation. So the tip is just to replace the all causal relation with the counterfactual dependence relation, and I believe this replacement strategy will be work, because we are not really going to understand the nature of causality or the counterfactual dependence. We are only to give the explanation of it about relying on it. So I think this strategy works. So now I am claiming that with this supplement, the CTE can characterize RG explanation since the pluralist counterfactuals are ruled out. So now we are just going to the role of irrelevance. Suppose the intervention in CTE applied to the RG explanation, or more precisely, its relevance aspect. So what is the conceptual resources that RG explanation provides in order to make the application done? So i.e., which is to ask, how does RG provide the interventionism condition? So my answer is quite simple. It's just because the RG irrelevance aspect, because it shows the counterfactual we found from the RG relevance aspects are independent of micro details, which distinguish each system in the same universality. And so we finally get the hotchpotch thesis justified. I will just read it out here. To summarize, with a reflection on how intervention in CTE characterize the relevant aspect of RG, we find that the irrelevance aspect of RG provides an explanation for why we can obtain the interventionist counterfactual by which common feature variable explain the universality variable. So this is the whole picture of RG explanation. And we can also find this structure of RG explanation also dogmatized with the multistage process of answering the university street we provide in the last part. So it says, so more precisely, the relevant aspect of RG satisfies the question 1, which is why there is a university class. And the irrelevance aspect satisfies the question 2, which is that being the same university class, molecular molecular distance system perform the same critical behavior. So we can see both aspects contribute an answer to the university tree. So, and I think I don't have enough time, so I just go through this part. Okay, so there are 3 take-home message. The first is the counterfactual theory is too weak to capture out non-causal explanation relationship, and it must be modified with interventionist character. And then the common feature theory and the irrelevance theory are not competing pair. Rather, they characterize RG explanation from different aspects and contribute together to its explanation. And the third point, I said it in potential objection, so I just read it out. Now, what are in RG explanation explanatory irrelevance factor is conceptually independent of identification of relevant fact. So this is the whole presentation.